It's Gray still plays. Let's do this. Sorry, Gray. Just keep on.
Hi, how are you doing? I'm going to teach you how to make sense of Feynman diagrams, know what all the squiggly lines mean, and work out if they're representing a valid particle interaction or if they're defying the laws of physics. Ugh.
More like the law of finance here. What I've been ripping anyways. When we're just looking at it, those colors are important. Hey, I know colors, guys. Yeah, you're not thinking right. Your brain's not working in terms of like why this thesis is kind of awesome. You can do this black and white. There's kind of the independent thesis of me just ripping this gray chart. But realistically, I still might come around with the color palette and start to break them down. This is a column, this is a column, this is a column. Might get a little squirrely. You can understand. You might want to go binary with what that setup is. Oh, because you can understand the collisions you would have, the arguments, and usually I like Weebles. It's pretty good. It has a nice individual rip on that shade system, so you don't get too much of this chop inside of there between this type of color palette. But green is really super important because it's the visible light spectrum. When you seen him in there, he had the E's come to the blue squigglies. I don't know why it does that, but it definitely does that. And when you think about the entropy, I mean, whatever one's first, if we consider white first, then that's the key on the brain. Gets a little choppy over here. You could understand the whole entire sector would need to be doing that until I get down to a subsector where those last two shades are a little dark, hard to read. My brain might pass over it in terms of what I'm really connecting on, because at that last back state they don't really like to catch so well on the brain. And there's some Buchholz averages, taking the subset of these averages because I'm just stealing the pieces off of it. I'm just getting in here and peeling off, whatever. That I would find a way to better precisely build a computer right for the moment, because it's also a time dilation argument of what I'm looking at here from our Laplacian point or our Fourier. And I said in the last video about the first of the year, because everybody's going to kind of agree with that type of cyclical nature. It's M1, M2, golden ratio, plus golden ratio, some junk high and low, right? And maybe you got some bacon and cake stuff where it's 3 in that squared inverted position about, well, yeah, and you could argue with the mathematician all day, and we're not necessarily... Maybe the chem lab could do something with that, because it's a pain right in the behind about what really chemistry is. It's a pain in the butt. Most people get it wrong, probability style, so you get all this voodoo inside there about it. But it gets a little bit more technically dark out there before that's just going to black out everything. Then I'll have to get into colors. I did not hit the right sector, but at least I'm still pretty key. The math still works when I go to change the colors of this, because I find out how many sectors there are, basically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like there's 11 sectors here, and that's by me doing the same thing over, getting the averages out, and utilizing. While we're in that sector, you're probably going to do a lot more than just this limited subset. Again, there's a total amount in there. If I just wanted to cover money for the sector, I got to bring $10,000 to the table roughly today, tomorrow, a few days from now. It's not going to get so crazy inside of there. I'm too crazy about it, but $1,100 or $11,000. The average stock, though, in the mediums of those things is ripping at about that 4,500 or 40. So I want a momentum driver on that black body problem of roughly what the largest one is doing and the smallest one is doing. Now, again, small works a little differently here, but I'm also not using the market cap, and I'm not integrating any free cash flows to higher preciseness and high frequency. Deal with that much. Let me get back in here because I'm not going to be talking about it. I've watched these videos many times. I understand there's that range within the spectrum. Oh, I'm supposed to have something else up here. Yeah, this bad puppy. well, the actually Drax equation stuff, and I forget the guy's name, but this will work because it gives me some really solid standard models to describe why they change colors, why there's a collusion symbol inside of there for what you're trying to do. And if you know your market diagrams by Fibonacci's, there we go, that's what I'm looking for, it will come in out of range. America, Dutch, well, Dutch, America, China, Russia, China, and China's on that last cycle, but you're trying to integrate the equation a little differently for the cat. Does it survive? Does it die? Is it within the homogeneous optics of what you're dealing with there? Um, So while we're doing that, you can see how that's a useful and interesting equation with what well, again, I'll go the other way here, with what we would be doing. Here again, I'm just in the grayscale shift of it, but I would kind of need to be because of the deep field that comes with that. There's X-ray, microwave, and there's an intensity differential in there. So it's not really that they're back to the standard model particle physics here. Yeah, I want to be over in here. Sorry. We're describing, so how do I take that energy in that Schrodinger's box with the colors and argue what am I doing to then adjust that wave function from corner to corner in here, because it may have some latitudinal lines or neutrinos that affect that system in terms of its operating procedures. Because more appropriately here, it'll move, all of those will move into opposite waves. They'll have some systems, you got to integrate a hurricane to really drive that over. The predictability is there's the or. You can say all this is mixed in, all the color palette is mixed in. Well, technically I can unwind that. That particle science says that the simulator can totally unwind that. I'm just not really sure what happened in the maelstrom by time standards. It's not something I could turn off or turn on. And inside of a stable tank of water, how stable is the tank of water issue that gets that generated. So regardless, I'll generate that system and see what cycles come over it before I get these wild pins or anomalies inside of the system that says giving those housing. That would equal not heat by the standard, but a position where those probabilities are very, very high. And if that's drowned in a bunch of seals in the pool by temperature that day, that means it's a little colder than our standards should appreciate, and that's going to cause all kinds of different hell later, but that's something different.